So this is the start of a series of videos on linear algebra. We're going to start by reviewing systems of linear equations, which is going to be the basis of most of what we do in linear algebra. So it's what we do in the first few sections will be used the rest of the semester. So just review again, what is a linear equation? First of all, linear equations sometimes are written in what we call slope-intercept form, y equals mx plus b. But in this class, we're going to write them in standard form, which looks like this: ax plus by equals c. And we're not limited to two variables in linear algebra. And sometimes we can have many variables. You might have 100 variables in a system. So in order to not run out of letters of the alphabet, instead of writing our linear equations like this, it's like a generic linear equation. We'll have coefficients. We'll call them a. We'll subscript them. So the first coefficient will be a sub 1. The first variable will be x sub 1. The second coefficient will be a sub 2. The second variable will be x2. And you can just keep going in this way until you get to the end. We'll say the nth one is a sub n and the nth variable is x sub n. And we'll call the constant on the right side b. Okay. So here's an example of a system where we've written those equations that way. Now, these only have two variables, but instead of x and y, we're just writing x sub 1 and x sub 2, right? So we're going to solve the system using elimination. And you probably remember solving systems by elimination in your algebra class. You also use substitution, right? But we're going to focus on elimination. If I'm going to solve this by elimination, I need to multiply the first equation by -2. So I can add -2 and +2 and eliminate this variable from the second equation. I could also multiply the second equation by +3, and I could eliminate the second variable. Okay, so there's not one way to do this, but I'm just going to do it this way first. I'm going to eliminate this 2x sub 1, and I'm going to multiply the first equation by -2 and add it, right? So that'll look like this. I'll just write it down here. So -2x sub 1, -2 times -3 is +6, and -2 times 6 is -12. And you remember this too, right? You make your little addition problem, and we add these like they're columns, right? So -2x1 minus 2x1, that's 0x1. And then x2 plus 6x2, that would be 7x sub 2. And 5 minus 12 is -7. So we've eliminated the x1 variable, and we can solve for x2. And if we divide by 7, we get -1. And now we substitute. We can pick any of these equations to substitute. I'm going to pick the first equation. So x1 minus 3 times x2 is -1, equals 6. And we're going to solve for x1, so that looks like +3. And subtract 3 from both sides, and we get x1 is equal to 3. So our solution is an ordered pair, x and y, right? Instead of x and y, we have x sub 1, x sub 2. And just before we move on here, I want you to think about, why is it okay to just add these equations like this? What is going on? Why does that work? You should pause the video and think about this. Why can't I just add these two equations like this and make this an addition problem? All right, so I'm going to tell you why. If I add negative 2x1 plus 6x2, if I add this to the left side and I add this to the right side of the second equation, since we're assuming both of these are true statements, we're assuming that this is 5 and this is 5. Therefore, we're just adding 5 to both sides, right? So you're just adding the same thing to both sides, and then you add those together, you get 0, so that eliminates that x1 variable, and then you combine like terms, right? Whoops. I didn't add those. So this is 7x2 equals negative 7. So you're just doing this problem in a way that's more visually pleasing, right? So what does this look like on a graph? So I'm going to solve both of these equations for x2, which is y, right? So if I solve the first one for x2, what do I get? Let's see. That's 6 minus x1. Then I divide by negative 3. Whoops. Divide by negative 3 is going to be negative 2 plus 1/3 x1. So that's your y equals mx plus b. So let's write it this way. 1/3 x1 minus 2. And then let's solve the second one for x2. This is going to be a lot easier. So negative 2x1 plus 5, that's my mx plus b for the second guy. And I'm going to type this into my calculator here. I'm going to hit the y equals. This is a TI-84 calculator. Y equals, and for the first one I'm going to put in 1/3 x minus 2. And for the second one, negative 2x plus 5. I'm going to graph it. So let's see. Looks like the blue line is the first equation and the red line is the second one. So you can see here at this point, 3, negative 1 is where those lines intersect. So this is the solution that is a solution to both equations, right? Is the ordered pair that you plug in for x and y, and it works for both equations. So that is when you're going to get one solution. So there's 3 options here. You can get one solution, and that's when you have in 2D, 2 dimensions, this is when you get intersecting lines. Right? You can get no solution when the lines are parallel. So if your 2 lines are parallel, you're going to get no solution to the system. This is in 2D again. And you can also get infinitely many. So when you get infinitely many solutions, you have 2 equations that have the exact same solutions. So you would just get one line graphed on top of the other one, and every point on the line is a solution. So an example would be, x plus 2y equals 3, and let's multiply this by 2, right? So 2x plus 4y equals 6. Multiplying this first equation by 2 on both sides does not change the solutions, but we do get a different equation, right? That's not the same equation. So if you got a system like this, you will have infinitely many solutions.